So, hello everyone, and welcome to this weekly session that we conduct, Ask AuxEn Anything. And as you all know, that this is an online platform for civil structural engineers to interact with us and ask their queries or doubts that they may have related to any steel RCC design concept or uh, or any project that they are doing or construction site issues. So this is the 44th such episode that we are conducting, and we will begin by taking the queries this week. So I'll first take the queries from the Google form, and then we will take the queries from live audience. So let me just start and share my screen. I hope my voice is audible to all of you. Yes. So the first query for this episode is from, let me see who has asked. Yeah, just give me a minute. I'm just opening that Google form. Okay, so first query is from engineer Jagat. He's from Sharjah, UAE. He is asking fees of the course. But it's not clear for which course he wants to know. So, Mr. Jagat, you can go to our website, and on our website, you will see the course details along with the course contents, and you will be able to watch the introductory session also and first session, as well as you will see the course fees details. So go to the website and have a look. Okay, the screen just got hung up. I don't know why. Just hold on for a minute. Yeah, so go to the website. All right. Next question is this screen visible? Let me just have a look. Yeah, it is. No. What happened? All right. So this was Engineer Jagat's question. Then moving on, and next question is from next set of questions have been asked by Engineer Ishan Desai. He is a working professional from Goa, and he is asking these questions. I'll just put it up over here. And I think he had shared one image also on WhatsApp. So let me just have a look. Uh, okay, he has put that in. So let me first take these queries. What is the maximum span of a cantilever slab one can give for balcony in RCC? So there is no restriction as such. No restriction as such on the span that you can go till. But then, if you could show the results of this case on ETABS or SAFE. No, so there has to be some specific case which I need to show you. So I'm not showing any case over here. But what is the maximum span? So no restriction as such. It will depend on the system that you can come up with. Okay, come up with. But if it's a residential, let's say a residential building, people are not people will not be ready to do a lot of things for long cantilevers, for long span cantilevers. Otherwise, uh, you may have to do some different structural system like Verindil girders or some 3D trusses. Some sort of those things may be required. In residential commercial constructions, people won't be ready to go or to invest so much on that. So I would say comfortably maximum span of around 7 to 8 feet is more than enough in small residential commercial buildings. Usage wise, I don't see any reason for going for having cantilevers more than this. Okay, so 7 to 8 feet is comfortable enough. Of course, as I just told you, you can go to longer spans also, but then you may have to introduce inverted beams, or you may have to introduce some 3D, as I just said, Virindil trusses or something like that, which may not be economically a great solution to have. So comfortably, just taking slabs cantilever 7 to 8 feet is good. His next query is maximum backspan of these cantilever bars if those bars can be lapped. So take it at least 1.5 times the cantilever span. That is the general, I would say, general sense that we have, that around 1.5 times you take it as a backspan and don't lap those bars till 1.5 times the cantilever span. Is it possible to transfer some moment to the beam by developing some bars and rest through the adjacent slab, and how the torsional constant to be adjusted accordingly? No, so just see, just by developing bars, beams will not start taking moments. For example, in this case, I am showing you a cross sectional view, and suppose this was a beam, and suppose this was a slab. Okay, and in plan view, this was something like this, that let's say it is continuing over here. So in plan view, and you had a beam in this location, at this location, and this was your cantilever slab, and this was your beam. So in this case also, this beam will have some torsion. Okay, that torsion might be because of to maintain the equilibrium. That torsion will be to maintain the equilibrium. So there will be some torsion in the beam. Now just developing the bars and hoping that the loads will be relieved from the beam, it does not work that way. It all depends on the stiffnesses, it all depends on the cantilever span, it depends on the torsional stiffness of this beam, it depends on the flexural stiffness of this slab. So just by developing bars, you cannot be, you cannot change the behavior. Please understand, the behavior depends on the rigidities and stiffnesses of these elements, individual elements in the respective actions. So torsional constant to be adjusted, I'm not sure what you mean by that, but please understand that developing bars carry no meaning. Uh, you have to understand the stiffnesses involved and how they are going to play out. Okay. Yes. Then, okay, related question over here. Mr. Yogeshwar Rao is asking how to withstand 8-meter span cantilever beam without back anchoring. Why do you want a 8-meter cantilever beam? I don't see any. I mean, 8 meters is a lot. Why do you want 8-meter cantilever beam? First of all, ask this question to yourself. And that too, you are saying without back anchoring. So, in these cases, let's say if this was a column cross section and you are saying you are taking 8 meters out cantilever and it does not have any backspan. I am showing you a sectional view. So I don't see the reason. First of all, ask this reason to yourself, to the architect, why at all an 8-meter span is required. And if let's say usage wise it is required, just having a 8-meter span without backspan, without backspan will not be stable enough. You will have to add other systems. For example, you may have to add, let's say, wire ropes, or you may have to add, if possible, some knee braces. Okay, or you may have to develop, as I was telling you, some three-dimensional truss system where maybe another beam you take it something like this, and then try to make a something on this face in the in this view. So these types of systems will be required. Just a normal beam 8 meters without backspan, you will not be able to stabilize it, and I will not recommend you to do that unless you add other systems like some, as I just explained, some wire ropes or some knee braces, etc. Okay. Mr. Mohammad Rehan is asking a related question. How can we provide backspan if there is cutout adjacent to slab and beam depth is also constrained? Yeah, so see, then these are specific problems. Then you will have to work your way around with your architect or with whoever is looking after the project. So if this was the beam he's saying, I'm showing you the plan view, and suppose there this is all slab. So specific cases you have to come up with specific solutions. Now, answer to every specific case may not be possible without knowing all the facts of the matter. But what I can understand is he's saying there is a, let's say, a cutout over here in plan. So now you cannot have this beam continued at the back because there is a cutout. So in this case, what to do? So it will depend, as I said, these are specific problems, specific doubts. These will require specific solutions as per your structural configuration, and then you can come up with solutions whether to shift this duct or then to maybe add another beam adjacent to this beam, whatever. Okay. So unless we have all the facts, specific doubts are difficult to answer. Okay. Yeah. Then the next query is from Mr. Ishan Desai has put another query. Let me just paste it over here and see and try to make a sense of it. So he has put this query and then he has put this image, and I think he has shared one more image. The column forces are transferred as point loads in ETABS, and we try to convert it into shell forces by assigning stiff to those slab members around those points and the forces which we input to SAFE file. But the stresses ultimately are being developed around those points in SAFE, which would not be a correct distribution of forces, I think. I'm not sure what he wants to say. and whether it's a question or a query. So I'll skip this because I have not fully understood what he wants to ask. Then moving on, just a minute. Then moving on to the next question. This query is from Engineer Rohit Dogra. He is from Himachal Pradesh and he is a working professional. He is asking, and this query many people have. So and we have also tried to explain this a couple of times earlier also. He is asking, in my ETABS model, I have a structural wall and a column system resisting lateral loads together. I want to transfer about 25% of the total base shear to column and remaining 75% to the walls. So this is the requirement, let's say, given in the ASCE 722 for dual systems. Okay. In ASCE 722 for dual systems, if you go to chapter 12, they have given this requirement that the perimeter frame. So let's say if you are going for a dual system, which is structural moment frame plus shear wall. So the perimeter SMRF system has to take at least 25% of the total earthquake load. Understood? That is the requirement. That is the requirement given in the code. At least 25% of the total earthquake loads. I don't think the language says 25% of the base shear. It says 25% of the earthquake load. There's a difference between those two. So let me just see first the language of ASC 7. Then this requirement is also given in the IS 16700-2023 code, where they say that the in well distributed shear wall systems, I think they say something like this 25% criteria. So how to go about this is the question asked. Let me just see what is the requirement given. Yeah. So it's not base shear. It is, let's say I'm taking a screenshot from ASE 7. ASE 7 says dual system with SMRFs capable of resisting at least 25% of prescribed seismic forces. There's a difference between resisting seismic forces and resisting base shears. All right. So now how to go about it is the query. Let me also have a look at the screenshot of this. Just a minute. Screenshot from IS 16700, and then we shall discuss. Anyone in the live audience who has this query as well, and anyone in the live audience who does this as per their own way? Yes, please. Anyone in the live audience who have been who had this query also, and or anyone who has been taking care of this provision through some procedure that they have developed? Just a minute. I'm just, yeah. So this, now this is a screenshot from IS 16700. Structural walls well distributed, it says. And here it says structural walls are considered to be well distributed when structural walls are that are outside the core are capable of carrying at least 25% of the lateral loads. Again, it's not base shear, it is lateral loads. All right. So let us see how you can mathematically try and do this thing. I have explained this many times before also. Let me try to explain once again. Suppose I had a simple frame. This was my wall. This was my, I'm showing you the plan view. This is my wall and these are columns and this is my beam. And in elevation, it looks something like this, that this is my column, then I will have a beam, then this is my RCC wall, again beam, and okay. Now what you need to understand that there is some lateral force acting. Now this lateral force will have two effects. One will be that it will cause some shears. uh, okay, yes, so let's say this is v1, v2, v3. Okay, so first just see, and this is easier to this is easier to see, that you just sum up the shears, just sum up the shears, and then try to get a sense of what is happening. So if you do this, you will find obviously that the total summation of shear forces that are developed, okay, are will be equal to your external force. Now if I were to ask you how much is the wall taking, what percentage of shear is the wall taking, and what percentage of shear is the column C1 taking, let's say, if I were to ask you, how will you find it out? So it's quite easy. If I were to ask you what percentage of shear the wall is resisting, you will say it will be equal to V2 upon V1 plus V2 plus V3, or V2 upon the total lateral force. So this gives you the percentage of shear resisted by walls. Now this does depend on the stiffness. So you will see in such cases that the walls will be taking the maximum shears. Columns will not be taking shears as high as the wall, because it depends all on the stiffnesses. Understood? But there is one more effect of the EQ force, that will be the overturning moments. Now, how are the overturning moments resisted? So understand that overturning moment will be resisted by, let's say, development of some moments, something like this. Plus, there will be axial tension compression couples also. So let's say here there is some axial tension compression couple, and it is compressive in this region. This distance is, let's say, I don't know, x1 is this distance is x2, and this height is h. So now how the overturning moment will be taken? So you will say EQ into H. This is the overturning moment developed. This will be equal to M1 plus M2 plus M3 plus T1 into X1 plus X2. Or instead of T1 into X1 plus X2, you can also write C1 into C1 into X1 plus X2, because T1 and C1 will be numerically equal. Is this clear? So now if I were to ask you that, tell me what percentage of overturning moment is being resisted by wall W, what will you say? So then you will say that the percentage of moment resisted by wall W is M2 upon EQ into H. Understood? Or if I were to ask you what percentage of moment are these two columns resisting, then you would say the percentage of moment these two columns resisting are M1 plus M3 plus uh, let's say T1 into X1 plus X2. Is this clear? Are you getting this? Divided by the total overturning moment. So this will be the percentage of moment resisted by columns. This will be the percentage of moment resisted by the walls. Now, how to incorporate this 25% criteria? How to incorporate the 25% criteria? So the easy way to do this is, Suppose this came out to be, you did the calculation, and just for example, this came out to be 18%. How? Because you just summed up these moments. You did this divided by the total moment. So it is coming out to be 18%. Now you want, as per your clause, of course, in this case, the well-distributed structural walls have to take 25%. In dual systems, the moment frame has to take 25%. Just take whatever. In this case, let's say I'm saying that the columns were part of dual system. They needed to take 25%. Understood? And right now they are taking 18%. So now how to ensure that they are able to take 25%? That is the question. Yes, please. Anyone with any uh, thoughts over here? Is this clear what I just said? This is the way you found out the percentage, approximate percentage of moment getting resisted. Because you must understand that earthquake forces or lateral forces will have two outcomes. One will be the shears that they create, and one will be the overturning movement. Shears, it's very easy. Shears mostly depend on the cross sectional area and stiffness, so that will not give you the correct picture. So it is always better to find out the overturning moment in this way, and then try and see what percentage are being taken by whom. And now let's say if you were to uh, if they were taking around 18%, you wanted to have around 25%. So a quick jugaad way of this can be, some in some cases some people suggest to apply modifiers. Okay, so you save your model under new name, and then apply modifiers in such a manner that these the moments flowing to the columns increase from 18 to 25. That can be one way, but then it means that you need to apply modifiers and do all those things. So instead of that, a simpler way can be that you just define a new load case in etabs. Let's call it eq1. Okay, define a new load case. Let's call it as eq1. And in eq1, how do you define it? So approximately 25 upon 18 times of eq. Understood? So for your original EQ force, it was taking 18%. You want your system to be designed for, let's say, 25% the columns alone. So you can use this as a multiplier, multiply it to EQ, create a new load case, and then use this load case, use this load case in load combinations uh, for design of the columns and beams, let's say, or the moment frame. So this case I took assuming that the external columns had to take 25%. You may have a case where the well distributed shear wall has to take 25%. Whatever is your criteria, in this similar manner you can do a quick jugaad work. Is this clear? So this is one of the easier way to do this 25% criteria for dual systems or for well distributed shear walls. So you find out the percentage and then see approximately how much percentage is being resisted. Then introduce a new load case and have this factor multiplied to your original lateral loads. Then you will, and then you can use those load combinations only for the 25% criteria or members which need to satisfy 25% criteria, and then design it. Understood? So this can be one of the ways to do it. Okay. Let us, I hope this is clear. Let us take next query. The next query is from Mr. Harish, Dr. Harish BA. He is he is member or a participant in our liquid retaining structures course. He is asking, I'll just explain what he's asking very quickly. Let's say this is a water tank sectional view and it is underground. Okay. and this is the NGL, ground level, and there is a water presence of water, and let's say that water table is still here. Okay, so this water table, and then of course there is a water inside also, because it's a water tank. There is water inside, and then there is presence of water table outside. So now what will happen due to this water table? This will first of all create an uplift on the raft. Okay, uplift on the raft. How will you calculate this uplift? How will you calculate this uplift? Let's say the depth of this tank was 5 meters from the ground level. Water table has risen up to 3 meters from the base. So what will be the uplift pressure acting on the tank? So naturally it will be what? Uplift will be equal to gamma W into, as per the rules of buoyancy, into 3 meters. So this will act on your bottom of the tank or base of the tank raft. Then, because of this water table, it is present over here. This portion of the soil is saturated, so it will apply, or there will be lateral pressures also due to this saturated soil or submerged soil. So now how do you do that calculation? So that I had explained, that let's say the submerged soil condition exists below the water table. So up to this distance, you apply this triangular pressure. This will be due to soil. How much will it be? Let's say this is 2 meters, so this will be Ka gamma soil into 2 meters. Okay, understood? Now below this, what will happen? This soil is submerged. So let's say gamma soil is around 16 to 18 kilonewton per meter cube density. Gamma water is around 10 kilonewton per meter cube. So gamma submerged is usually how much? Gamma soil minus gamma water. So how will we apply pressures over here? So one component will be the submerged soil. So this will be Ka gamma submerged into this depth. To this you add the presence of water. So this will be gamma W into 3 meters. Okay. So in this manner you can apply the loads. Is this clear? Okay. So this was Dr. Harish BA, and this was his query. I think in the earlier question, a related query was, as per IS 1893, core walls should resist 100% of shear force. I am talking about dual systems. What I explained in this thing was dual systems. Okay. Yes. For dual systems, just have a look at the ASC 722, chapter 12, or have a look at the IS 16700. Good. So after this query, let's move ahead and see what else has been asked. Mr. Rohit Dogra, he is asking, there are two clauses for time period. Page number 16, 17, point B and 2 closer to each other by 10%, away from each other. Refer to Mr. Rohit, just refer to the Ask AuxEn Anything session that we had conducted last week, or I think last to last week. I'll share the link with you. There, this same query has been taken. So just go to that episode and have a look. Okay, this same query has been explained over there. Okay, moving ahead. Engineer Abhijit Sathe is asking. He is a working professional from Pune. Uh, what is he asking? Let me see. What is the effect of column shortening? So effect of column shortening, he is asking. See, columns, because they are axial members, and any axial member subjected to load will develop a strain. Okay, and any strain will create uh, any axial load naturally will create P by A stress. Okay, and if you were to divide it by E, it will naturally create strains, and any strain, compressive strain, will create shortening. That is natural. You cannot control it. I mean, you cannot not have axial shortening. Understood? It's not possible to not have axial shortening. It will always be there, because it's a property of the material to shrink, sorry, to expand or contract when acted upon by loads. And it's not a rigid material. Please remember, both concrete and steel don't have infinite rigidity. So if they have a certain modulus of elasticity, so there will be strains. Because of those strains, there will be shortening or elongation. So you cannot not have them, but yes, you can control it. So by controlling it means, as far as possible, we generally try to have uniform shortenings. Okay. So uniform shortening means, let's say if you have your tall building, and this problem, why we are talking more in tall buildings, because tall buildings will have large column axial loads which you may not get in normal buildings. And when there are large axial loads, you may get significant axial shortenings. Okay, so as long as the stresses developed in these columns are more or less uniform, the shortening will also be uniform. Understood? So uniform shortening is not a problem. Uniform shortening is not a problem. All right. When does the problem occur, or when does it become a problem? When the axial shortening is non-uniform. What does it mean, non-uniform? So non-uniform means, suppose I have this type of structure. Just to give you an example, let's say I have a central core, and I have connected it by outriggers. Okay. Now what happens, because of these outrigger systems, most of the load is flowing to the periphery, and this undergoes a lot of, so there is a large variation in the axial stresses in this element and in this element, let's say. So this was a central core, these were my outriggers. So in this case, there will be large axial shortenings in these columns. The central core may not have such high shortenings. So now, because of the differential shortenings, there can be a problem. Okay, that is a problem. So what does it cause? Because of this axial shortening, there will be non-uniform settlements, and because of those non-uniform settlements, you will get large movements in these elements, which then you have to design. So axial shortening, when it becomes differential or non-uniform, then it becomes a problem. So then you will have to control it, either by making adjustments in your configuration, or by designing it, by considering that. Or some people, what they do is then that they will postpone this construction to a later stage. So let's say they will have these columns, they will have these cores, and at a later stage they will go for the construction of this outriggers, let's say. Or in some cases, they try to have some allowance or some provision to, uh, sort of, what is the word, to accommodate the differential settlements in these outriggers. So some adjustments like these are then made. Construction sequence, how does it affect our building moment and shear forces? So this has been discussed in detail in our tall buildings course. I will suggest you to have a look how construction sequence affects. Basically construction sequence, because your stiffnesses change, your moment distribution changes. So with the change in moment distribution, with the change in stiffness, the force distribution also changes, and that is taken care in the construction sequence analysis, which you can do, and which becomes important for taller buildings. Not your 7 8 story, it does not become important. That becomes important for your taller buildings. So in our tall buildings course, we have discussed this issue in detail. You can have a look at that course. Okay. Then next question is from who is asking? Uh, Mr. Pratish Avasthi. He is a working professional from Indore, and he is asking: is there any criteria? Is there any criteria given in the code for floating columns and its design and number of floating columns we can provide? No, no such criteria is given. You can provide any number of floating columns as you wish. Only thing the code says is that if you have floating columns, those frames which have floating columns cannot be part of your lateral load resisting system. Only this thing code says. Otherwise, code does not have any additional guideline or criteria on the floating columns. So he is just elaborating. There is a proposed hotel building in Ujjain in which at some places ground floor wall grids are not matching with first floor wall and second floor is residential unit. Okay, so you may introduce floating columns. Just remember that the frames which have floating columns cannot be part of lateral load resisting systems. Good. Next query is from engineer Akash Babar. He is a working professional from Mumbai, and he is asking what should be the effective length factor for shear walls. Yeah, it shall be same as your columns. So the procedure remains the same. Okay. Effective length factor calculation procedure remains the same as you do for columns. Okay. There is a related query that has been asked by engineer Sheikh Jawad. In design overrides for beams, we have ordinary, ductile, and non-sway. What is the difference between ordinary and non-sway design overrides? See, for beams, it does not make much of a difference. For beams, the only difference will be if you are using ductile, then it will follow the rules of ductile design detailing, IS 13920. If you are using ordinary, it will follow the rules of normal IS 456. For columns, it does make a difference whether you are using ordinary, ductile, or non-sway. So it does make a difference, and this point has been very well explained in one of our earlier YouTube live sessions. So what I will suggest you that you can go to this our YouTube live session on project discussion series episode 1. Okay, you will find that on YouTube channel, our channel. So go to project discussion series episode 1, and I think go to 26:51, 26 minutes 51 seconds in that video. You will find good explanation on ordinary, ductile, non-sway columns and what are the different settings for them and how it impacts the design. Okay, yeah, so just go over there. Okay, then taking on the next query. Next query is from who is asking the next query. Next query is engineer Sundaraman from Hyderabad. He's a working professional. So he's saying, he's asking rather, he is designing a PEB shed in STAD with a Proflex sheet, 10-meter height, 20-meter width, 40-meter length. Should the effective length of column be taken as this, assuming it has to be cantilever column? Yeah, you should take it. See, ideally you should. What he is asking is that he has a system which is something like this, okay, and then there is a roof sheeting, self-standing roof sheets. So in these types of systems, what happens is that they are self-standing. That means they do not require any rafter or nothing. This arch itself is self-standing. So he is using this type of a system, and his question is that his question is that how to. So this is 20 meters. He is saying this is 10 meters height, eaves height. So now this, see what happens, that this essentially, these columns essentially become like a freestanding cantilevers because they don't have any translational restraint in this direction. You may have a beam placed, but that beam is along the length. So along the width, you don't have any translational restraint. So this more or less acts like a freestanding cantilever. So in this case, he is asking whether the effective length should be taken as, in cantilevers we take it two times the length. So should we take the effective length as 20 meters? That is 2 into 10. That is what his question is. So yes, I agree. You should do it this way. Okay, you should do it this way. Yes. And my suggestion in this case will be that uh, go for some built up columns, PEB type of. If you use plate sections, you may not get a good best solution. Try to go for built up columns, lacing batten, so that you can achieve economy. Or even better, if you can go with RCC column beams. Okay. Yeah. And another point on this, that this system will not be uh, cost effective if you don't have a good soil strata, because what will happen, there will be large movements that your footing foundation system has to take. So if you do not have a good strata, this system will not be cost effective. So just have a relook. People think that this is a cheaper system, but actually what you save on the Proflex sheeting or roofing, uh, you end up spending in the superstructure and substructure. Okay. Yeah. So this was his query. Moving ahead, Mr. Nikunj Pandarikar from Latur, he is asking how to model steel staircase connecting footover bridge in STAD. Can you give me some advice here? He has shared one image also. Let me see what he has shared. Let me just see what he has shared. Piers are already cast, he say. No, so what advice do you want? I didn't understand this question. What advice do you want? You have the plan, you have the section, make a staircase. If you want to learn modeling on STAD, you can watch some YouTube videos. What advice do you need? You already have the details with you. So yes, this is his section. This is his plan view. You have the column positions. Everything is there. What advice do you need? Okay, if you are watching this live, may reply. All right. So I'm not sure about what advice he needs. Which method will be suitable means you go with a line modeling. Line modeling for staircase. Just use simple line modeling technique and just make one flight. So if all your flights are same, or if they're different, let's say you can take, let's say, this flight if you wished, and just make a line model like this. Okay, it's not even necessary to make both the flights and treads and everything. Just make one line diagram, just one, make one line model, and take the loads that will be transferred on this, and design your single line model like this. If you want to make a complete thing, then you will have to take all these columns till respective heights, and then make all proper line diagram, line models, whatever. So then in 3D view, maybe you will have to make like this, and then have these columns till whatever height they are having. Okay, then maybe from here it rises up to the next level, and columns, so whatever. So then you may have to make a complete system. But usually for these cases, ISMC 175 to ISMC 200 shall be good enough. So try those members for your staircase beams. Okay. Use a channel. Channels are easy because your staircase treads can be easily connected on the channel members. So try using ISMC channels and make your line models like this. Okay. Okay. So this was Engineer Nikunj, and so these were all the queries that were asked on the Google form. So now we can take up queries from the live chat. So Engineer Saurabh Srivastav is asking, good morning, I have joined. Yeah, so he has joined this course on AISC steel design. He had a doubt regarding the M5 curve, MJRD value. Okay, so MJRD value is generally used for calculation of the connection stiffness. So for example, if this is your M5 curve, moment rotation curve of your connection, MJRD is the joint resistance. MJRD is the joint resistance. So his question is, MJRD value is calculated based on member capacity or based on external force? No, so MJRD is the joint resistance. So it is calculated based on the connection that you have provided and member. Actually, it is connection. So based on the connection, what bolts or what welding, what stiffener, what gussets, depending on that, MJRD is calculated by the software, and then at two-thirds of MJRD, this line cutting the M5 curve at two-thirds of MJRD, the stiffness of your connection is given by the slope of this line. Okay, so slope of this line means basically it will be the moment at two-thirds MJRD divided by the rotation at this level phi. So this gives you the connection stiffness, and then this connection stiffness you compare with the codal values to ascertain whether your connection is rigid or pinned or in between, semi-rigid, that is. Okay. So Engineer Sheikh Jawad questions we have answered. Uh, Engineer Mr. Magaj is asking how to apply tuned mass dampers in ETABs. Please provide some reference. I don't have any knowledge about it. Neither do I have any knowledge of the appropriate references. I've never done tune mass dampers. Anyone in the live audience who have some reference? No, I guess. All right. So then the next query is from engineer Tamilarasan. Give reference books for design of purlin with cold form Z shape with lip section as per IS code. Again, I don't have any reference. I don't know of any books. Uh, so anyone in the live audience, if they have any, what should I say? If they have any reference that they know of, kindly help. Option buyer is saying, please take my doubt from WhatsApp. Please take my doubt from WhatsApp. I also send you screenshot. I have already taken the doubts asked on WhatsApp. Kindly identify with your name. So if I have left any query, I'll take it up. Mr. Hassan and Mr. Option Buyer, just tell me with what name you have sent your query on WhatsApp. I think I have taken all the queries that were asked on WhatsApp also. If it has not been taken, just inform me the name or number through which you have sent your query. Okay. All right. Then, oh, okay. Intikab was asking. Yes, yes. So you did not put your query in the Google form, is it? That's why I forgot. That's why I tell you to put your query in the Google form so that I don't forget it. Yes. So Mr. Intikab Hassan, he is a working professional. He had asked this query. Is it necessary to check wall punching or only pile punching? How to check punching? Can you please explain? So in this case, let's say he has this is the plan view as I understand, and this is his wall that he's having. So his query is that this is his wall, shear wall or core wall, whatever, and then it is resting on a pile cap, and those pile caps are resting on these piles. So in this case, he is asking how to check for punching. So see, wall in because of the shape, wall punching is not a big problem because of the shape that you have, because of the geometry that you have. Wall punching may not be problem. Wall one-way shear is a problem, and those one-way shears, and also you will not get these results from the software. So you try to check for the one-way shears, and one-way shear in the wall will be concentrated in these regions quite naturally. One-way shears will be concentrated in this region near the wall face. So try and see these one-way shear values. Okay. So you may look at the V13, V23 stresses, or directly you can go for shear stresses output in ETABS and try to see that they are less than the concrete capacity. And when it comes to pile punching, yes, in the case of pile, you will have to check both the one-way shear and two-way shear both, and pile can punch through the pile cap, so that has to be checked. Now in this case of pile, the code says that you need to check even the one-way shear at dy2 distance away from the face of pile, not at d distance. For pile checks, the code asks you to check it at dy2 distance, so you do that check also. Okay. And check for the two-way punching or two-way shear as well. So wall in this case, only one-way shear check is good enough. For piles, you check it at the dy2 distance from the face of pile. All right. Is it clear? Okay. Then, uh, okay, Mr. Magaj is asking, continuing to ask that water tank question, how to resist uplift pressure. So, resisting uplift pressure, you may use different strategies. One of the strategy is to take out these types of extensions in your raft of your water tank, something like this. So what happens is, and let's say this is your ground level. So because you have taken these extensions, what happens that the soil will help you to counterbalance the uplift. Okay, so you may do this calculation, what is the weight of soil, and then see what is the weight of what is the uplift created by this water. Now see, in underground tanks, if your tank is full, then uplift is not a problem because water is inside. Generally it will add a lot of weight. Problems may be in case of tank empty and water table outside. So in rainy season, let's say you had water table rising up to some height and tank was empty, then uplift can be a problem. So try to counter the uplift by adding soil. And how to add the soil? By taking these extensions. If even that is not sufficient enough, then you may have to think of providing some underpinning arrangement. So that may be done in soft soils. You may try to incorporate some piles, underream piles or friction piles. If your underground tank is resting on hard strata, you may go for some uh, reinforcement underpinning or reinforcement connection to the strata below. So these can be some of the strategies to uplift the water pressure. Mr. Mohammad Rayan is asking gravity columns. We have answered gravity columns a lot of times in previous episodes. I'll tell you which episodes you can have a look at. Okay, good. So I think that we have taken all the doubts. We have taken all the doubts from the Google form, and we have taken all the doubts from the live comments also. Anything else anyone wants to ask? Okay, so I think that's all for this episode then. That's all for this episode then. Thank you so much for joining. Oh, Mr. Magaj is having a query. For example, 30 kilonewton per meter square uplift pressure tank is this. Then can go with slab design only or come up with beam and slab scheme. Now, so see, there are two things over here. First, you must understand that first, the mechanics of the system have to be satisfied. Okay, so let's say you had this. So first, ensure that this 30 kilonewton per meter square uplift in empty tank condition, it does not create, and your tank size is 15 meters by 30 meters, you're saying. So uplift created will be how much? This much. Okay, so how much is the answer? 900 into 15. So this much kilonewton is your uplift pressure. So first you have to have some system which can take this 13,500 kilonewtons of pressure. So maybe in tank and empty condition. So just try to counteract it by having this soil fill. Okay, that is number one. Then if that is satisfied, first the equilibrium has to be satisfied. If the equilibrium is satisfied, then for this uplift pressure you will have to design the raft. So now in raft you can use any system. You can use thick slab system, but then it will require very large thickness. So you can do a beam slab system for the raft. If your slab spans are too high, I'll suggest you to introduce some internal columns so that those columns act as support for your raft. and thereby reducing the spans of your raft. Okay, so that's what you can think of. So first point is to manage the equilibrium and then think about designing the raft for this pressure. Okay, Mr. Intigab is asking any course where you have covered gravity column design. I think in the flat slab systems course that we have conducted, we have done this situation, or we have discussed this case of gravity columns. Okay, Mr. Rishabh is asking horizontal projection as per IS 1893 clause. Can you explain? Which is this clause, horizontal projections? I don't know. Which clause you are talking about? That five times for horizontal cantilevers, five times the vertical earthquake. Is that the clause you are asking? I'm not sure which is this horizontal projection clause. Let me see which is this clause, horizontal projections. Horizontal projections. No, I'm not sure. If you have a screenshot, acceleration for cantilevers. Yeah, I think that clause says five times the vertical earthquake force we have to apply. Five times AV or something like this. Is that what you're asking? So in that case, you may have to first calculate this vertical earthquake, and vertical earthquake will be two-thirds. I think the vertical earthquake acceleration coefficient is two-thirds of horizontal acceleration coefficient. Then you will have to define it in ETABS maybe. For that definition, you can go to some good videos on YouTube how to do that definition. If not, it's very simple. For let's say large horizontal projections, we just calculate its weight. You calculate the weight of this horizontal projection, and you will have the AV. So just do AV into W. That will give you the vertical force that has to act, and just do five times of this. I think this is what your code asks you to do it. So even manually you can do this thing. If you did not want to do it on ETABS or STAT, just calculate the weight of that projection. Calculate five times AV, multiply it by the weight. You will get the force and design your cantilever for that force. So something like that you can do. Or you can define it in ETABS, define the vertical earthquake in ETABS, and then apply it to your system. I think it will also then take care for the uh, it will take care for the projection. Mr. Pratish Avasthi is asking, please describe the criteria. I just answered, Mr. Pratish. I think you were not there. I answered this query a little while ago. Just go back in the video and see over here. This is your query, and I have answered it. Just go back in the video and have a look. Okay. All right. So I think that is all for this session then. Thank you very much for joining, and we will see you next week now, where we will take up questions as we always do. So during the week, if you want to ask your questions, you can continue to put them in the same Google form. So we conduct this live session once every week, but the Google form remains the same, where you can keep putting your queries. So this is the Google form, and if you want to connect with us on WhatsApp, you can send a message uh, to us using this link, which I'm just going to put. Let me just paste that link. Where is the link for WhatsApp? So this is the link I have put if you want to connect with us on WhatsApp. All right, so then this is it for today's session. Thank you everyone for joining. We will see you again next weekend. Till then, have a good time. Bye bye.